All right, hey guys, we got a new episode coming at you. So we're going to be talking about solving quadratics by factoring. Again, quadratic is any function with the highest power of 2. And by factoring, hopefully you did the warm-up to review what exactly factoring is. But without further ado, let's go ahead and get into it. So before we can solve by factoring, we need to understand something called the zero product property. And it sounds like a mouthful, but it's really not too bad. And what the zero product property says is you can take the problem you have and you kind of, I view it as like it's separation. It's separated by parentheses, and what you do is you kind of cut the problem in half wherever the parentheses are. And what you do is you set one factor. So the first one's x minus 9. So this is x minus 9. You set that equal to 0, and you also set the second factor, x minus 8, equal to 0. So you kind of cut the problem in half and set them both equal to 0. And then you solve for x. So these are really simple because you add 9 to both sides for this one, and you're left with x equals 9. And this one, you add 8 to both sides, and then you're left with x equals 8. So this problem actually has two answers. So we say x equals 8 and 9. Like that. So you said you cut it where the parentheses are for the zero product property to work. So for this problem, this next problem is going to be a little bit more complicated. But what you do is you kind of cut the problem in half and you say 4k plus 5 equals 0. And then you say k plus 7 equals 0. And then you just solve it like it's a normal equation. So this one, I'd subtract 5 from both sides, and have 4k equals negative 5. And then you divide by 4. And so you're left with k equals negative 5 fourths. You can leave it as an improper fraction. For this one, you would subtract 7 from both sides, and then you're left with k equals 7. So again, this problem has two solutions. So we say k, and it's more appropriate to write the smallest one or the negative one first. So we say k equals negative 5 fourths, and it equals 7. Okay, cool. This last one, Anyway, this one's a little bit different because you can see how there's an n and then the parentheses. So again, what we're going to do is we're going to separate it at the parentheses. And when I was in school, this type of problem would always trip me up, and I wouldn't separate the n. I would always forget about it. I'd always get points taken off of it. So it's still two separate problems. We say n equals 0 and n plus 2 equals 0. This one is already taken care of. We don't have to do anything, but I would always forget that. So it's important when you see the separation that you include it, and then you subtract 2 from both sides, and you have n equals negative 2. So the solutions for n, we say n equals negative 2 and 0. And the reason what the zero product property is, if you plugged in any of our solutions into their problem, it'd give you 0. So really fast, we'll just do the last one. N times n plus 2. And if I plugged in either negative 2 or 0, let's just plug in 0. So if this becomes a 0, 0 times anything is 0. So it's just showing you that any number you plug in is going to get you 0. All right, cool. So we need to know that to solve by factoring. So here we go. Steps to solving by factoring. These will be on the next page, but if you want to pause the video so you can write these down. Solid. Glad you paused it. But we're going to make sure the equation is always set equal to 0. Factor out any common factors. Then factor the remaining trinomial using the diamond method, which is where they add up and multiply. And there's factor A and factor B. And then use zero product property, which is what we did on the last slide. And that's, solve for x. So here we go. Step 1, make sure the equation is set equal to 0. So while we're just starting, it is going to be set equal to 0, but that's not always the case. Taken care of. Good. Step 2, is there anything I can factor from all three of these? Well, 2 of them have an x, but it has to be all 3. Can't factor anything out. It's always good to check. It makes it a little bit easier. Step 3 is factor the remaining trinomial using the diamond method. So I need two numbers that multiply to give me 15, but add up to 8. Excellent. If you said 3 and 5, you are correct. So my two factors are x plus 3 and x plus 5, and those both equal 0. Boom. I guess I should have wrote blue because it's in blue. But anyway, cool. Then it says use the zero product property. So that's when we say x plus 3 equals 0 and x plus 5 equals 0. Then finally, we will solve for x. So I'm going to subtract 3 from both sides here. So x equals negative 3. And x will also equal, because you're going to subtract 5 from both sides, negative 5. So we say x equals negative 5 and negative 3. Those are the two solutions. All right. Don't forget, solution is another word for x-intercept, also root and zeros. Zeros. There we go. Second problem. Same process. So as you're doing this, what similarities does it have as the first problem, second problem? Anyway, step 1 says set the equation equal to 0. So I need to move this 18 over to the other side. I don't like that orange. That's very burnt orangey. And by doing that, I'm just going to subtract 18 from both sides. So I have 4x squared minus 21x minus 18 equals 0. There we go. Took care of the first step. Boom. Then we're going to check to see if there's any common factors. Well, a 4 and a 21. No common factors. That's okay, but it's always good to check. Step 3 says we're going to factor out the remaining trinomial using the diamond method. So that I need two numbers that multiply. And this one's going to be a little bit different because there's a number for a in the front. But I need two numbers that multiply to give me, what was that? Is it 72? 18 and 4? Yeah, negative 72. And add up to negative 21. So two numbers that multiply to give me negative 72, but add up to negative 21. They are, I'm kind of thinking, it's not 9 and 8. Let's see, 72. I believe it is negative 24 and 3. Yeah, that's it. Okay, good. So then we're going to rewrite this problem with this middle term change. So it's going to be 4x squared minus 24x plus 3x minus 18 equals 0. So just the only thing that changes this middle term became what these two are. All right, cool. So from here, you factor by grouping and say, okay, well, what does the first group have in common? So they both have a 4x, and what's left over is x minus 6. And if you remember, whatever is in this set of parentheses must also be in this set of parentheses, so that's also x minus 6. And then you can say, okay, well, 3 times what is 3x, or negative 6 times what is negative 18? It's going to be the same answer. It's going to be positive 3. So then my two factors are 4x plus 3 and x minus 6 equals 0. Boom, step 3 taken care of. Now we're going to use the zero product property. So we'll set them both equal to 0. 4x plus 3 equals 0 and x minus 6 equals 0. Awesome. Then let's solve for x. Subtract 3 from both sides. And you have 4x equals negative 3. Then divide by 4. And that one's x equals negative 3/4. And you have x equals positive 6 as well. So those are your two factors, your zeros, your x-intercepts, your roots. Boom. All right, last problem. You guys are doing great. So this is going to include all three. Step 1, set the equation equal to 0. So I need to move this guy all the way over here. And to do that, we're going to add 4r to both sides, so plus 4r. So you have r cubed minus 5r squared minus 4r, plus 4r equals 0. Boom. Set it equal to 0. Step 2 says factor out any common factors. Well, they all share in r. So I'm going to pull out an r, which means this is r squared minus 5r plus 4 equals 0. Sweet. Factor the remaining trinomial using the diamond method. So I need two numbers that multiply to give me 4, but add up to negative 5. So this one should hopefully be easy. Two numbers that multiply to give me 4, but add up to negative 5. Are going to be negative 1 and negative 4. So my two factors are going to be, so I'm going to have the r from right here. So r times r minus 1 times r minus 4 equals 0. Cool. Zero product property, we're going to set them all equal to 0. Now you're going to notice that I need to set 1, 2, 3 things equal to 0. Don't forget that r. There's a reason why we did it on this problem. So r equals 0. And kind of a cool, unrelated, but whatever the highest exponent is tells you the max amount of solutions. So this one is 3, which means there's at most 3 solutions. If you look at all the quadratics, they're always 2, which means at most there's 2 solutions. So if this was, r to the 5th, there would actually be, 5 solutions at most. Anyway, so r equals 0, r minus 1 equals 0, and r minus 4 equals 0. Cool. So we're just going to solve for r. This one's already taken care of for us. Add 1 to both sides. We have r equals 1. Add 4 to both sides. So r equals 4. So our final solution, we say r equals 0, 1, 4. Great. Don't forget to rate, like, and subscribe. Okay, thanks. Bye.